Let's have a look at the very next question. Now, puddles of water form on a path after rainfall on a windy day. In terms of molecules, state and explain how the rate of evaporation of the puddles is affected by a reduction in wind speed. A reduction in wind speed reduces but doesn't completely make zero the rate of evaporation. A reduction in wind speed reduces the rate of evaporation, but it doesn't make it zero. An increase in water temperature, consequently increases the rate of evaporation, as an increase in temperature results in an increase in kinetic energy. Thereby, the more energetic water molecules evaporate at a faster rate, thereby increasing the overall rate of evaporation. Figure 5.1 shows two puddles. We have a larger puddle which has a greater surface area that is open, and a smaller puddle which has a consequently smaller surface area that is open or in contact with the atmosphere. State and explain how the rate of evaporation from the larger puddle compares to that of the smaller puddle under the same conditions. Under the same conditions, the larger puddle has a greater rate of evaporation, greater rate of evaporation, owing to the fact that it has a greater surface area that is in contact with the atmosphere. Moving on, describe an experiment to demonstrate the difference between the good and bad emitters of infrared radiation. You may include a diagram to help your description. State what readings should be taken. Now, here we can take a very simple experiment to demonstrate the difference between good and bad emitters of infrared radiation. We can just take an infrared emitter, and we can take two different infrared emitters, in fact, which have comparable rates of emission of infrared radiation. Now, the readings that should be taken are the thermometer readings of the source as it emits infrared radiation and that of the surrounding environment, which is subject to the emitted infrared radiation. Now, we will make sure to use good thermometers which have no zero errors or which have the same value of sensitivity to avoid going wrong in our measurements. Now, with these suitable measurements made, we can find out which are good and bad emitters of infrared radiation, simply owing to the fact that a good emitter of radiation will cause the change in temperature much faster than that of a bad emitter.